Good afternoon, class. I am just finishing up Unit 10, Lesson number 9. It's on dilations, and I'm going to post this to YouTube today, and then I'm going to do the unit review tomorrow, and probably by Wednesday have it fully completed. Anyways, the guided practice was number 1 through 6, but number 1 and 2 has to have like a ruler, and so I think number 10 for the independent practice is the same type of problem. It's not going to be on your test, I don't believe. So if you have a ruler at home, complete them. If you don't, then it's okay. But the ones that we can do, I'm going to go over. So number 3, it says determine if from B to B prime is an enlargement or a reduction. Find the scale factor of the dilation in X. So B, if you notice right here, is this tiny um, triangle, and then B prime is this triangle enlarged to this bigger triangle. So it includes this entire area plus this portion right here. So if we look, it wants to know if this is a reduction or an enlargement. So from B to B prime, this triangle gets larger. So that's going to be an enlargement. All right. And then it says find the scale factor of the dilation of X. So then we have to look at um, these two variables, well, this variable X and 6. And what we're going to do is say 6, because that's from right here, this portion, plus, or times X. So 6X equals the total length. Because a dilation is, or a reduction or enlargement is going to be a scale factor, and a scale factor is a number that you multiply the variable by. So if we have 6x equals 8, we're going to solve for x. And if we do the math, x is going to equal 8 over 6, and we're going to just simplify by dividing the numerator and denominator by 2. So that gives us a enlargement of 4/3. So the scale factor is 4/3, and it is an enlargement. Again, we have 6 and x, and the whole total length of b prime is 8. So we're going to go 6x equals 8, set up a equation, and solve for x. All right, so number 5 is another type of problem that we're going to look at in the guided practice. It basically it says graph the image of each polygon with the given vertices after a dilation centered at the origin with the given scale factor. So we have W is at 0, 0. We have X is at 6, 6. Y is at 6, 0. And we have K equaling 1.5. So what we're going to do is we're going to graph both of these these vertices. So I'm going to graph this triangle because that's 3 points and they're all connected. So the vertices, if there's 3 of them, it's going to create a triangle. So W is at 0, 0. X is at 6, 6. It's like right here. And Y is at 6, 0. So it looks like a right triangle. Okay. Now, in order to do this problem, what we're going to do, we're going to multiply each of the terms, or each of these numbers, by 1.5. So W prime is going to be 0 times 1.5, and then 0 times 1.5, and that's going to give us W prime is at 0, 0. We're going to do the same thing. For X prime, we're going to have 6 times 1.5, and then 6 times 1.5. Getting a calculator, that's going to be 9. So x prime after the dilation is going to be 9 and 9. And lastly, we have y prime, where we're going to have 6 times 1.5 and then 0 times 1.5. And that's going to give us y prime is at 9, 0. So here is our new coordinates after the dilation. All right, so we have a point still at 0, 0, at 9, 0, and then 9, 9. So it's just going to go like this. So x prime is right here at 9, 9, and y prime is going to be at 9, 0, and w prime and w is at 0, 0. So that's pretty much how you would do problem 2. All right, or problem 5. So let's go on to the last problem I want you to pay attention to. It is problem 6. So problem 6 is the same type of problem. So we have Q at -4, 4. We have R at -4, -4. And we have S at 4 and -4. And then we have T at 4, 4. So this is a quadrilateral of some sort. It could be a rectangle, it could be a square, I don't know. So we're going to graph it and see. So it's the same type of problem. We have a scale factor of 1/2. So if you have a scale factor of k less than 1, that means it's going to be a reduction. If it's greater than 1, it's going to be an enlargement. I'm going to just draw it on this big axis. Okay, so we have a point at -4, 4. It's Q. We have R at -4, -4, right here. We have S at 4, -4. And then we have T at 4, 4. So it looks like it's a square. And now, in order to get Q prime, we're going to take -4, multiply it by 1/2, and then 4 and multiply it by 1/2. And that's going to give us -2, 2. And then R, the same thing. For R prime, we're going to have -4 times 1/2, and then -4 times 1/2. So you're taking -4 dividing by 2, you're going to have -2, -2. And then for T, we're going to have 4 times 1/2, 4 times 1/2, and that equals 2, 2 for T prime. And S, I accidentally skipped S. We're going to have 4 times 1/2, and then -4 times 1/2, and that equals 2, negative 2 for S prime. All right, so now we're just going to graph Q prime is at 2, negative 2, 2. So it's right there. R prime's at negative 2, negative 2. S prime is at 2, negative 2. And T prime is at 2, 2. So we just drew a square right here, this smaller square, as a reduction based on this larger square, QRST. So we have Q prime, R prime, S prime, T prime. And all we did was we take the scale factor and multiply it by each of the numbers in the coordinate, and that gives us our new scale factor. So here's Q prime, R prime, T prime, and S prime. So that concludes lesson 9. Essentially, like I said, if you have to do problem 10, I would omit that unless you have a ruler. And then you could do number 15 through 19 and also 21 through 22. Literally, those are the same type of problems that I just did as an example. So I will be posting this right now to YouTube and get you the unit review tomorrow and no later than Wednesday, because it's a lot of problems and I'm going to do a lot of them. Anyways, have a great day and stay safe. Take care.